It's my pleasure to introduce David Yu today. David comes to us after getting his undergraduate at Simon Fraser University in Canada. Then he went to National University of Singapore for his master's, and then got his PhD at Arizona State, where he was a research associate for about a year, and then came to us at Purdue as an assistant professor in 2015. David works in the area of what is called as socio-hydrology. So there is hydrology and then there is society. So some of his conclusions, I find them very intriguing. The moment you bring in people, it looks like all the math goes out of the window. But I'll let David talk to you about his journey, and I look forward to hearing from him. David.
Sure, thanks. Yeah, so thank you all for joining, and thank you to the College of Engineering for organizing this. So I'm David Yu. So I want to begin with a brief intro of myself. So that's my family. So I have a 3-person family. Bonet Creek Elementary School parent. Okay, and I was promoted 2 years ago in spring 23. So I was supposed to give this talk almost 2 years ago, but I went on sabbatical, live abroad to Seoul, South Korea in 23, 24. So that's why it got delayed. And this is related to the central theme of my talk today. It's that my path, my life and my path has been at the boundary of very different things. So culturally, I'm a Korean Canadian living in the U.S. as a permanent resident. So my son, right after he was born, he got citizenships from 3 countries. So I'm at the boundary of these different cultures. In terms of work, many people look at it strangely, but I'm at the boundary of College of Engineering and the College of Liberal Arts. So I have 75% appointment in civil engineering and 25% appointment in the Department of Political Science. So I came to Purdue in 2015 as part of cluster hiring done by these 2 colleges on the theme of building sustainable communities. And my education is also very different. So undergrad engineering, master public policy, PhD in sustainability science. So Kathy, he's asked me, to talk about what led to my success. So I thought about it. So I had some successes, but and I may appear to be successful, but has it always been this way? No, I don't. That's not my experience. It has been. So my path has been a long journey of struggles to define who I am and what I do, and it's because my research interest took me down a long interdisciplinary path to the study of social ecological technological systems or social hydrological systems, however you want to call it, and it has been it's a path that is again at the boundary of very different things: system science, study of environmental governance, and engineering. So what do I do? I study social hydrology or social ecological technological systems. It's an integrated systems approach and thinking that explicitly captures humans and human interactions with the built environment and their natural environment. And I try to investigate how these systems can be resilient and sustainable in the face of external shocks and social issues. So that's what I do. And how do I do this? I apply this kind of a triangular approach. Looking at governance design, aspects of civil infrastructure design, and how that shape human behavior, that in turn generate system level outcomes like resilience and sustainability. So that's the what I do, and why do I do this? The idea is that this kind of approach can reveal patterns and processes that are not evident when this social parts and physical parts are studied separately. Um, yeah. So what is social hydrological system or social ecological technological system? So let me give an example. So a complex watershed system like this with precipitation and stream flow, uh, civil infrastructure like multi-purpose reservoir dam that control for flood and supply water and other objectives, and the human social organizations that operate the infrastructure and people who depend on benefits generated from this infrastructure. That's like what you can think of as socio ecological technological system or socio hydrological system. So that's and traditional like engineering focused approach would kind of narrowly focus on the infrastructure and would raise a normative question like this: how the operation of this infrastructure ought to be done? And they would use methods like dynamic programming and multi-objective optimization. So a researcher would undergo this kind of process steps to generate this optimal water storage levels across different times of year. But the sets approach or interdisciplinary approach would take a more positive inquiry, asking questions like how this operation actually is done. So if you look at this figure here, let me change the pointer. Yeah, so this is the target storage level of reservoir dam that's instituted by some agency based on this optimization work. And this red curve is the actual water storage levels that are observed. So why is there this kind of discrepancy? So this is based on human discretionary judgment exercised by reservoir operators. So this is you clearly see deviation from the recommended and target level. So why is this happening? So I would ask questions like, why this happens, and can behavioral and human cognitive factors can explain this discrepancy, and what the resulting insights imply for the management. So that's the kind of approach that I take. So how did I become? So I just showed you the kind of approach and interdisciplinary research that I do. So how did I become what I am today? So I want to go back in time and kind of walk through my life. So I was born in South Korea, and and as you can see here, I was totally like liberal arts literature person. So I enjoyed my math and engineering was average, but I really loved reading like books. Like I recall when I was in fifth grade, I read books by Per Buck and Hemingway. And so that was my passion. I even wrote short stories of my own and rented it to them to my friends. So I was totally like a liberal arts person with average math. But all this changed. My family immigrated to Vancouver, and my average math in the standard of Korea suddenly became very excellent in the standard of Canada, and and uh, and my strength in reading and writing became my weakness. So I kind of shifted towards more math, science person, and I ended up going doing studying engineering science for my undergraduate study. So I had this transition in my early years, and then I had my first major experience of success and failure. So when I was in fourth year, three people, me as an engineering student, another student in computing science, and then another biology undergrad student. Four of us got together, and it was like at the tail end of a dot-com bubble, and in the middle of human genome project hype, we started a bioinformatics software startup company, and it's miraculously we were like 23-year-olds, 24-year-olds, but we succeeded in getting a venture capital seed funding of about $800K. So it was just I was ecstatic, and it was a great experience. But to make a long story short, the company failed and it dissolved. That dissolved after 3 years, and so I was brokenhearted, and I needed a change of environment. So I went to Uzbekistan, a country in Central Asia, for half a year to work as a short-term, part missionary, part volunteer worker at a NGO organization there. So I lived there for half a year, and I learned many things. I learned what it's like to live in a less developed country. I realized how blessed and lucky I was to get an education in North America and to have opportunities in North America. I learned that in Uzbekistan, and after that, I went back to South Korea to work at this big company as a software process engineer, and so I enjoyed my time there, and I was fortunate to meet a good manager, Mr. In Soo Hwang. He encouraged me to write conference papers based on the work I did. So as an employee in the private industry, somehow I wrote 4 conference papers, and so that was a big turning point for me. It kind of got me interested into academia, and it brought back my memory of writing with creativity. Because to me, writing short stories and writing scientific papers, it seems similar, and it required creativity. So I saw some connection in those two things. So in hindsight, I think all this prepared me for my path as an interdisciplinary scholar. So my early years allowed me to develop enthusiasm for engineering, both engineering and social science. My time in Uzbekistan made me appreciate graduate education and opportunities in North America. My time as an entrepreneur and time in Samsung made me think that made me realize that I had preference for creative and immersive research over repetitive work and corporate politics. And all in all, this writing papers, short stories, or conference papers, it made me realize that I have joy of writing with creativity. So after 7 years in industry, I went to graduate school. I went to National University of Singapore for a master in public policy, focusing on environmental policy. And after 1 year of study and after working as a research assistant under Ed LLR, I also had a little turning point. His advisor, Lee Ostrom, who was at IU, she got Nobel Prize in economics. So that got me more interested in pursuing education. So I was told that a bunch of her students went to Arizona State, and they do kind of cool interdisciplinary work, applying her ideas and thoughts. So I went to Arizona State to do PhD in sustainability science. I focused on this topic of resilience and governance of irrigation infrastructure systems. So it was a highly interdisciplinary research that combines applied math, systems thinking, and environmental governance. So anyhow, I really benefited from my advisors. My advisors were basically applied mathematicians studying a couple of natural and human systems that includes infrastructure. And they themselves were trained by these pioneers of interdisciplinary research. So Luna Strum, she was pioneer of connecting governance, state of governance, and complexity science. Rodriguez Iturbe, hydrology and ecology, Simon Levin, math and ecology, Brian Oker, C.S. Halling, ecology, management, and math. So so I really stand on the shoulders of these giants and their influences. So I think, and I also got this training as a PhD student on how to use these different methods. So this is my approach. I study case studies and comparative analysis of them, and then based on them, I kind of come up with phenomena of interest or hypothesis. Then I would test those hypotheses and phenomena using behavioral experiments and systems modeling composed of dynamic modeling or agent-based modeling, and based on that, I generate some insights. And that's the kind of cycle of research that I do. And my PhD work led to these publications. You know, and so these papers are highly interdisciplinary at the boundary of social science and engineering. Um, and then right after PhD, miraculously, Purdue hired me, so I came here. But I think now in a while I have joint appointments in two colleges. So here at Purdue, I continue the same path, doing interdisciplinary research. So this is one of the NSF project that I've done. So in this project, I ask question. I study water reservoirs, and I study why is there this question: why is there a discrepancy between rules, like target water storage levels, and actual operation? Are there some cognitive biases or behavioral heuristics of operator that explain this discrepancy? What are resulting implications in long-term drought and flood trends, right? And I developed a systems model and generated this results that inform management. In another project by NSF, Humans, Disasters, and Built Environment Program, I raised this question: why do some societies have disaster memories that are widely shared by its members for a long time, while others forget them quickly? And after a couple of generations, people re-experience these floods again, right? So under what set of conditions can a society collectively forget disaster, or sustain them to mobilize actions that are required for resilience? And so for this, I'm currently running behavior experiments. So I would create a micro society participated by humans, and then I kind of recreate this generation of people who play the situation, and they can kind of pass information across generation, so that I can test this hypothesis on collective memory of people. So that's my current ongoing research. So this is my self-reflection. So my life and work, as you saw, has been at the boundary of very different things. Culturally, academic discipline, methods, very different things. And it has been challenging, and it was not easy, And so those could be viewed as my weakness. Yeah, but looking back after all these things that have happened, I can say that cautiously, maybe those weaknesses can turn into one's strength, and maybe I'm a case of that. And I thank Purdue for hiring me and giving me tenure, even as an interdisciplinary scholar, recognizing this strength, right? And my plan is to continue the same interdisciplinary path in this great community of Purdue and West Lafayette. So that's all for my talk. Thanks. Oh, yeah. I want to acknowledge my my mentors, like GS Govindaraju, PhD Rao, Uxri, Nice, Linda Lee, Abraham Dulce, Professor Sina, Professor Murray, Jacko, and all other people in CE. My mentors in political science, Sherry Maestas, Claude, Rosie Carson, Jay McCann, Lee Raymond, and Jelma at FNR. I appreciate my students, and I also appreciate the funding agencies that supported my research. Yeah, thank you.
Thank you, David. Does anybody have any questions for David?
Yeah, I have a question.
Wait, just a second. Pass the mic.
You, you're saying about the memory about disasters. There are too many. Recently, there are too many disasters. So people, difficult for all those to remember. So do you have any comments about the recent events that are taking place?
Yeah. So I think people generally have limited bandwidth on what they can remember. So we kind of focus on like major events that have impacted our society. So, for example, we're recruiting were surveying and recruiting people to study, participate in my research in Houston, and I would ask them about what they remember about Hurricane Katrina. I mean, this kind of major events. So even though there are many other like events that have happened, those are like really strong, memorable events. So they would remember. So I kind of work around that by focusing on major catastrophic events. Yeah.
I have a question. So you talked about this dam and the water levels, but you never told us what is the main finding. Why did the operator react this way? So I'm curious that you finish the story.
It's again related to memory. So it turned out. So we tried a different different. We kind of programmed represented different cognitive biases that humans can have, and it turned out that this is from psychology, something called salience bias. So it's a type of heuristic that humans are known to exhibit. So if people kind of act in a way that reflect what was most severe event in the past. So if if an operator had experienced major droughts in the last 10 or 20 years, he or she would be kind of biased to operating reservoir to create to store more water, even though it was not. The rule says you should not store more water in preparation for the floods. So it seemed this model of human behavior explain actual observed storage level of this reservoir. So that's why
Because somehow there was never an overshoot. So when I looked at that, I thought it's always the differential, right? Oh, I'm not having enough. I'm not having enough water. So okay, at this time, 2008-01, I'm going to overshoot a little bit. Oh, now I'm above the water level I should be. Okay, let me reduce it a little bit. It's almost like this delayed response. But you're saying that's not correct.
Yes. They were clearly influenced by what they experienced in the past. So but the thing is, as you saw in California, a region like California, they undergo through like a decade of drought and then a couple of years of severe flooding, right? So that's when that kind of thing happens, and people kind of were influenced by their past experience, then bad things can happen. So those were like kind of things that were we found in this research. Yeah.
Any more questions for David? All right. If not, thank you, David.
Yeah. Thank you, guys. Thank you.